So here's chapter 3, problem 56. The problem asks us to find the sum of the x and y components of these four vectors p, q, r, and s. It also wants us to find the magnitude of the sum of both of these vectors. And it also wants us to find the angle that the sum makes with respect to the positive x-axis. So to start, we're going to find the sum of all the x components of these vectors. So we're going to take the first x component from P. It's going to be 23 times the cosine, 16 degrees. And that's just the magnitude multiplied by the cosine of the angle. That's going to give you the x component of all of these. The next one is going to be from vector Q. The magnitude is 8.1. Going to multiply it by the cosine of the angle that it makes with respect to the positive x direction. Positive y is 90 degrees away from positive x. So we're going to do 90 degrees plus that 7.7 degrees that it's talking about. The next one from vector r is going to be the magnitude 12 meters times cosine. This is going to be clockwise from minus y. Minus y is 270, and 25 degrees is going to be 25 less than 270. So this angle is 270 minus 25 degrees. And then we're going to say the last one will be, I'll write it down here, plus from vector s, 15 times the cosine of 30 degrees counterclockwise from minus y. So that's going to be 270 plus 30 degrees. And that should give us the sum of the x components as 23.45-ish meters. So now we're going to do the same thing, but to find the y components, we're just going to use sine instead of cosine. The angles are all going to be the same, but it's just going to be 23 times the sine of 16 degrees plus 8.1 times the sine of 90 plus 7.7 degrees plus 12 times the sine of 270 minus 25 degrees plus 15 times the sine of 270 plus 30 degrees. And that's going to give us about negative 9.499 meters. And again, just to find these, it's the magnitude of the vector times the cosine of the angle for the x component, and the magnitude of the vector times the sine of the angle for the y component. The trickiest part is probably the different directions that the vectors are pointing. So you're going to want to convert them all to be pointing in the positive x direction. Otherwise, the answers are not going to make total sense. But that's that. That's how you get the x and y components, or I should say the sum of the x and y components. Now we need to find the magnitude. The magnitude is going to be pretty straightforward. I'll just write magnitude is going to be equal to, it's the square root of the sum of the squares of the components. Our x component is right here, y component is right here. So we're going to take 23.45. We're going to square that guy. We're going to add it to negative 9.499. Square that one. Take the square root. It's going to give us oops, there we go. It's going to give us about 25.303 meters. And now the last thing we have to do is find the angle that this sum makes with respect to the positive x-axis. We have the sums of the components, again, with respect to plus x. So now it's as simple as taking the inverse tangent of the y component divided by the x component. That's going to be minus 9.499 divided by 23.45, and choosing the quadrant correctly and all that stuff, we're going to get an angle of about minus 22.05 degrees. And that is how you do problem 56 from chapter 3.